VFR training, you learned several methods for keeping track of your position and navigating from one place to another. You learned how to use pilotage and dead reckoning. And you learned basic radio navigation skills using VOR and ADF. As you transfer to instrument flight, your knowledge and understanding of radio navigation must increase, since your outside visual references are replaced by instruments. The ability to visualize your position is one of the most important IFR skills you can develop. It makes IFR navigation much easier. With that in mind, let's review some of the basics of VOR navigation as they relate to IFR flight. We'll begin with this clearance from departure control.
Warrior 312, 5 miles northeast of Jackson VOR, intercept Victor 77 and resume your own navigation.
As you can see, it's always important to know where you are. To intercept the radial, the first thing you need to do is visualize your position in relation to where you want to go. In this case, you are to the east of Victor 77, which is the 020-degree radial from the VOR. With the VOR indicator set to the 020-degree radial, the CDI shows a full-scale deflection to the left. This means you are more than 10 degrees from the radial. To find out where you are, rotate the OBS until the needle centers with a from indication. In this situation, you're located on the 060-degree radial from the station. Now that you know what radial you're on, you need to choose a heading that will enable you to intercept the 020-degree radial. The angle of interception depends on several factors, such as your ground speed and proximity to the radial and navigational aid. A wide range of angles may be suitable. One possibility is to fly a 90-degree intercept to the 020-degree radial. In this case, you need to anticipate your turn onto the airway, since a 90-degree standard rate turn takes 30 seconds. Another choice is to intercept the radial at a smaller angle. For example, a 30-degree angle is commonly used for en route operations. For this intercept angle, you must maintain a heading of 350. As you approach the radial, the CDI helps you anticipate your turn onto the course. At standard rate, the 30-degree turn will take only 10 seconds, so the amount of lead is relatively small. Although the basics of VOR tracking and bracketing are the same for both visual and instrument flight, these skills need to be fine-tuned for IFR navigation. It is important to realize that, as you fly away from a VOR, a deviation from your desired course represents a greater lateral distance. Each dot represents a lateral distance of 200 feet for every nautical mile you travel away from the VOR. For example, at 5 miles from the VOR, a 1-dot deviation means you're about 1,000 feet away from the course. But at 30 miles, this same deflection places you about a mile off course. Another skill you need for IFR navigation is identifying an intersection that is based on VOR. Here, you identify Walto by the intersection of the airway and the 270-degree radial from Duncan VOR. One indicator is used to navigate along the airway. The other one is tuned to the Duncan VOR, with the OBS set at 270 and a from indication. When the needle centers, you are at the intersection. Another method for identifying an intersection, as well as keeping track of your position, is through the use of distance measuring equipment, or DME. The equipment on board your airplane transmits a radio signal to the selected ground facility. This triggers a response back to the aircraft, where the time lapse is translated into your distance and time from the station, as well as your ground speed. Remember that DME measures the slant range distance between your airplane and the ground station, rather than the horizontal distance. Although the slant range error is negligible at long distances and low altitudes, it may become significant at high altitudes when you're close to the station. For instance, if you pass over the station at 12,000 feet AGL, the DME will show approximately 2 miles instead of 0. Now, let's take a look at an instrument that combines the features of the VOR and the heading indicator. The horizontal situation indicator is gaining popularity because of the abundance of navigation information it provides in a pictorial display. The compass card provides you with headings, just like a normal heading indicator. The course selection knob functions like an OBS and moves the course arrow to your chosen radial. The lateral deviation indicator is similar to the CDI and senses your position with respect to the selected radial. The ambiguity indicator functions like the to from indicator and shows whether the selected radial will take you to or from the station. The airplane symbol in the center of the HSI represents your horizontal situation in relation to the nav aid. A glide slope indicator shows your position relative to the glide slope. You'll learn its importance later on when you practice instrument approaches. To see how easy the HSI is to interpret, assume you are southwest of a VOR on a heading of 360 and want to intercept the 270-degree radial and fly inbound to the station. The first thing you do after tuning and identifying the station is to set the inbound course of 090 degrees. Notice the ambiguity needle shows that this course is to the VOR. With an HSI, it is easy to visualize your position. The relationship between the miniature airplane and your intended radial is shown by the lateral deviation needle. You know that you're flying toward the radial at a 90-degree angle. Choosing an intercept angle is simple with an HSI since it provides a visual presentation of your aircraft heading and your selected course. Let's assume you want a 45-degree intercept. After turning the airplane to 045 degrees, notice how the instrument shows your angle as well as your new heading. As you approach the radial, the needle will begin to move towards center to signify that you're nearing the course. You can gradually shallow the angle depending on your rate of closure to smoothly intercept the new course. You might have to adjust your heading slightly to compensate for the wind. Let's now look at the benefits of an automatic direction finder. ADF has a wide variety of uses in the IFR environment. You can use it to receive weather information and to provide position orientation during en route flight and instrument approaches. Since the navigation signals are not limited to line of sight, you can receive them at lower altitudes and greater distances. Let's take a moment to review how bearing information is given. On a fixed card ADF, you determine your magnetic bearing to a station by adding your magnetic heading to the relative bearing. In this case, the magnetic heading is 030 and the relative bearing is 090. This produces a magnetic bearing to the station of 120 degrees. Your text covers the fixed card ADF in detail. With a movable card, you can dial in your magnetic heading and the needle will point directly to the magnetic bearing. To demonstrate how to visualize your position and navigate with ADF, assume you're on an easterly heading and you want to intercept the 360-degree bearing to the NDB and track inbound. After identifying the station, you find that your present position is on the 020-degree bearing to the station, as shown by the head of the bearing pointer. Rather than use a 90-degree angle, you decide to turn left and intercept the bearing at 30 degrees. Your heading in this case is 030 degrees. By setting your magnetic heading under the top index, you can use the head of the bearing pointer to show your position in relation to the bearing. When it indicates 360, you have reached the bearing. In actual practice, you should begin your turn just before you intercept the bearing. This reduces the possibility of overshooting the desired course. Since the ADF does not automatically provide a wind correction angle as a VOR does, let's review the bracketing procedures. In this example, you've drifted right of the 360-degree bearing to the station. The ADF is sensing a crosswind by pointing to 350. To regain the course, you apply a 10-degree correction into the wind and reset the ADF to match your heading. If your heading and relative bearing remain constant, you've corrected for the drift, but you will not intercept the 360-degree bearing. So, an additional correction is needed. In this case, you are using a 20-degree correction angle to regain the course. If you continue to keep the ADF heading aligned with your magnetic compass, you can verify that you have returned to the course when the head of the bearing pointer equals 360 degrees. To remain on course, use just enough crab to maintain this magnetic bearing. The last navigation instrument we'll look at is a radiomagnetic indicator. The RMI lets you continuously monitor your heading as well as your position from two nav aids simultaneously. While one needle indicates your magnetic bearing in relation to an NDB station, the other shows the magnetic bearing to a VOR station. To see how this instrument works, assume you're flying north along an airway on the 180-degree radial of a VOR. An intersection ahead of you on the airway is identified by the 090-degree bearing to an NDB. With an RMI, you can navigate along the airway with one needle while continuously monitoring the ADF pointer. When it points to 090, you are at the intersection. As you continue northward, the bearing pointers provide a perpetual display of your position relative to the two stations. Precision IFR navigation depends on your ability to visualize your position, interpret the instruments, and quickly select headings that will intercept or maintain your desired course. The accuracy of the information you use is a vital part of this process. For this reason, the FARs have established procedures for checking the VOR equipment and the maximum permissible bearing errors for IFR flight. The VOR equipment in the airplane must have been operationally checked within the preceding 30 days. It is your responsibility to ensure all your equipment is within acceptable limits prior to an IFR flight. IFR navigation, attitude instrument flying, and instrument interpretation are the foundation upon which all instrument flying is based. Mastering these skills will enable you to efficiently operate in the IFR environment.